Hey, this is Professor Perez again. I'm back for part 2 of scientific notation. Now, in this presentation, we're actually going to write numbers in scientific notation. We're going to do a review first, and then we'll get to those problems. Anyway, let's see what Charlie's up to. He better be ready to go. Hey, Charlie, ready to go?
No.
This is part 2. Here we go, right there. Now, in the first part of this presentation, we learned that multiplying by powers of 10 moved the decimals. If it was a positive exponent, it moved to the right. If it was a negative exponent, it moved to the left. And so, let's kind of review what we found. Okay? If we have 10 to the 4th, well, 10 to the 4th means 10,000. That's 10 times 10 times 10 times 10, right? 10 cubed means 1,000. 10 squared is 100. 10 to the 1st is 10. Remember, 10 to the 0 power is 1. Remember, anything to the 0 power is 1, except for 0 to the 0. Okay, that's undefined. And 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 10 squared. 10 to the negative 3 is 1 over 10 cubed, which is 1 over 1,000. And 10 to the negative 4 is 1 over 10 to the 4th, which is 1 over 10,000, right? Okay. Now, 10 to the 4th. In scientific notation, if you're multiplying a number by 10 to the 4th, it moves the decimal. Which way, Charlie?
To the right.
To the right 4 times. 10 to the 3rd moves the decimal. Which way, Charlie?
To the right.
To the right 3 times. 10 squared moves the decimal. Which way?
To the right.
Right 2 times. 10 to the 1st moves it.
To the right.
1 time, right, to the right. 10 to the 0 doesn't move it. How about 10 to the negative 1, Charlie?
To the left.
That's to the left. That's right, to the left. 10 to the negative 2 moves it which way, Charlie?
To the left.
To the left 2 times, that's right. 10 to the negative 3 moves it which way?
To the left.
Left 3 times, to the left. And 10 to the negative 4 moves it which way, Charlie?
To the left.
To the left 4 times, that's right. All right. Okay, anyway. Now notice here that positive exponents move the decimal to the right and negative exponents move them to the left, Don't forget. Okay. So, 2.35 times 10 to the 4th. We're going to work on this problem right here. Okay. Now, which way is decimal move, Charlie?
To the right.
To the right 4 times. That should be easy. That's right. That's our review there. Negative 5.489 times 10 to the negative 8 moves the decimal which way?
To the left.
To the left 8 times. There we go. And there's your answer there. Now, some of you have said, hey, I forgot how to do my place value. Yeah, I know you're out there. And you too. Okay. How do you read this number in English? What do you say? If somebody gives this number, can you read this to me? What do you say? Point 50489, something like that? Well, let's try to read this number. Let's review our place values. Remember, there's a pattern to this. Okay, that decimal is showing you where the ones place is. So there it is. Remember, your pattern is always ones, tenths, hundreds. If you go the other way, okay, it goes ones, tens, hundreds, 1,000s, 10,000s, 100,000s, 1 millions, 10 millions, 100 millions. Well, that pattern goes the other way, right? Okay, watch right here. There's our ones. It goes ones, tenths, hundreds. Okay, then take a break. Now here we go again. Now it's 1,000s, 10,000s, 100,000s. Take a break. Now, here we go. 1 millions, 10 millions, 100 millions. Take a break. And now, 1 billions, 10 billions, 100 billions. So that 9 is in the hundreds billionths place. So this number is actually read, it's negative 5,489 100 billions. Now that's a good question for the dinner table tonight. See if they can answer that. Okay, let's do another one here. 7.00305 times 10 to the negative 5. And what we're going to do here is write in scientific notation. Remember, the decimal moves which way, Charlie? To the left 5 times. How do we read this in English? Okay, here we go. Ones, tenths, hundreds, 1,000s, 10,000s, 100,000s. Take a break. Okay, 1 millionths, 10 millions, 100 millions. Take a break. 1 billionths, 10 billions. So that 5 is in the 10 billionths place. So how do we say this number? It's 700,305 10 billionths. Oh, what fun. Remember, another question for the dinner table tonight. Okay, so notice in these examples, we're taking the numbers out of scientific notation. Now we're ready to put them back in scientific notation. So here we go. 425.89. 425.89. Here, we got to move the decimal so that we get a 1 or a number greater than 1 but less than 10 to the left of the decimal. See, here's what I mean. Notice here, we move the decimal to the left 2 times, and that gives us, Charlie, up there, 4.2589. Well, our original number was 425.89, and so we need to multiply this number, 4.2589, by 10 squared to move the decimal back right 2 places. So in scientific notation, 4.2589 is multiplied by 100 to get 425.89. There we go. So another one. Here's one right here. Okay, 0.0000136589. So here we got to move our decimal to get a number just to the left of it between 1 and 10, or equal to 1. Notice here we got to move it, what, 5 times? Okay, to get 1.36589. Now, we have to move the decimal. The decimal was shifted 5 places, so here we need to multiply by 10 to the negative 5, because that will move the decimal to the left. So, we see that 1.36589 times 10 to the negative 5th, okay, is divided by 100,000, which is 10 to the negative 5, to get that decimal number up there. Okay? Let's do another one, negative 0.005007. So here, we have to move that decimal, okay, to the right 3 times, because that'll give us the 5.007. It's negative. Remember, the number just to the left of the decimal has to be 1 or greater than 1, but less than 10. Now, remember, we shifted the decimal 3 times, so in order to represent the decimal number that we started with, we need to move the decimal to the left 3 times. And so here, in scientific notation, negative 5.007 is divided by 1,000 to get negative 0.005007. Okay? So negative 5.07 times 10 to the negative 3 does represent that negative 0.005007. Okay, now here's one. It's a little tricky here. We got 1,000.0001. That's 1,000 and 1 10,000ths, right? Now, which way do you move the decimal place here, Charlie? To the left. Okay, you got to move it to the left for 3 times, right? Now that gives you the 1.000001. Okay, and so now, the decimal was shifted 3 places, so in scientific notation, we must multiply by 10 to the 3rd power. That puts the decimal place back in the proper place, and this was meters, okay? And so, remember, 10 to the 3rd means 1,000. Remember, in the metric prefixes, Charlie, 1,000 was represented by what?
Kilo?
That was the kilo. So, 1.000001 times 10 to the 3rd meters is 1.00001 kilometers, okay? Remember, kilo means 1,000 or 10 to the 3rd. So 10 to the 3rd is replaced with kilo. So 10 to the 3rd meters is kilometers. Okay, let's do another one here. This is a very small time. It's 107 something. Well, I don't want to talk about that right now. Okay, anyway, which way decimal got to move, Charlie? We got to move 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times to get the 1.07. Now, we shifted it 9 times, so we got to move it back to the left 9 times to get that representation that we started with. Now, 10 to the negative 9. This is seconds, okay? Now, 10 to the negative 9 was what metric prefix, Charlie?
Nano?
It was nano. Very nice. So, 1.07 times 10 to the negative 9 seconds is the same as 1.07 nanoseconds, because nano means 1 over 1 billionth, which is 10 to the negative 9th. And right there completes our lecture on scientific notation. So be sure you practice, and we'll see you all again soon.